All right, we're continuing with our Unit 5, Day 1, notes, solving systems of equations. We've solved systems of equations using graphs, and also we started solving our systems by using the substitution method. And so we did the first 4 problems already. We're going to move on to problems 5 and 6 here. This is our second video on this information. Okay, so looking at these 2 equations, remember what we want to do is substitute in information for one variable into the other equation. So we're going to try to isolate one of the variables. Y is, it has a coefficient of 1, so it's going to be really easy to isolate. So I'm going to rewrite this equation as y equals negative 2x plus 18. Okay, same line, it's just written in a different way. And now I know then that I can plug in negative 2x plus 18 into the y spot in that first equation. So I'll have 6x plus 3. It's 3y, but I know y equals all of this, negative 2x plus 18, and it all equals 54. And so now I'm going to use distributive property. I have 6x minus 6x plus 54 equals 54. Okay, when I solve that, I end up with 54 equals 54. I have lost my variables. So what this tells me, I look, 54 equals 54 all of the time. This is probably going to be all real numbers, right? I got infinite solutions here. So if I wanted to graph that, I would find that the lines are exactly the same line. The first one is exactly the same as the second one. So something else I noticed right when I was starting to do this problem, I noticed that I have 6x plus 3y equals 54. And I know 6 and 3 and 54, they're all divisible by 3. So if I had just wanted to simplify this upper equation, watch this. I'm going to divide every single thing by 3, the whole equation, every single term. So 6 divided by 3 is 2, so I have 2x, plus 3 divided by 3 is 1, so that's just y, equals 54 divided by 3, 18. Well, if I had simplified that equation in the first place, I would see that these are the same equation. So of course they're going to be the same exact line and have all real numbers, infinite number of solutions. Every ordered pair that works for one works for the other, since it's the same line. So you are allowed to manipulate these equations. If you notice that you can simplify one of them, go for it. And then you have smaller math to do. All right, so over here I have x plus 5y equals 4. And so I'm going to isolate that x all by itself. So this means that x equals negative 5y plus 4. So I'm going to plug that into my second equation in my x location. So I have 3 times, instead of x, I'm plugging in negative 5y plus 4 plus 15y equals negative 1. So I have negative 15y plus 12 plus 15y equals negative 1. Negative 15y and positive 15y cancel each other out, but now I have total nonsense, right? 12 does not equal negative 1, even though that's what my math says. And I know it's not true. 12 does not equal negative 1, so I know these must be parallel lines. No solution. So they have the same slope. If I were to graph them, they don't have the same y-intercept, and so there is no place where I have an x and y combination that works for both. All right, so for your classwork, I'm going to go ahead and write out solutions. And I'll write them out, but I'm not going to walk through talking about them. So I'm going to pause my video, write out the solutions, and then turn the video back on. Just double check your answers, make sure that you agree with my answers, and email me if that's not the case. And notice that we're asking you to solve numbers 1 through 4 by substitution, which is what we were just doing. Isolate one of those variables, excuse me. And then for 5 and 6 down at the bottom, where we've given you nice, handy graphs, go ahead and solve those by graphing. All right, so pause the video, do your problems, come back and check and see if you got the same answer as me, and good luck. All right, here's our first problem. I isolated that y, and I came up with y equals negative 2x plus 9. Then I plugged in that information, negative 2x plus 9, into the other equation, and I solved for the only variable that I had left. I solved and found out that x equals 2. I plugged x equals 2 into my lower equation, just because that one looked simpler to me, but you could have chosen either one, and I found that my y value is 5. All right, so if we look at number 2 here, we can see that we have, hang on, sorry. We can see that if we, sorry, my original notes were incorrect on this version. So your equations were x plus 4y equals 0 and 3x plus 2y equals 20. And so if you isolate for x, you can see that x equals negative 4y. And you'll end up with the ordered pair 8, negative 2. Okay, looking back at number 3. Number 3. Sorry, let me get myself to number 3. I rearranged that first equation, and I ended up with x equals 3y minus 2, and when I substitute that into my lower equation, I end up with the ordered pair negative 2, 0. Now remember here, if you wanted to, you could divide each one of these by 2, just to make your math a little bit smaller, and you'll end up with the same, each one of these terms is what I'm saying. So you could have rearranged this and said 5x plus 4y equals negative 10. All right, number 4, you start isolating that top equation, you isolate the y, so you end up with y equals 3x plus 8, and if you solve all the way down, you'll end up with the ordered pair negative 1, 5. You can pause here and you can see step by step what I did. Okay, and then number 5, number 6, we are solving by graphing. So I generally put each one of my equations in slope-intercept form and then graph them. And you find that your ordered pair here is negative 5, 4, and your ordered pair here is over at this spot, and it is 6, negative 7. All right, thanks for watching.